Hello everyone and welcome to this lecture. In this lecture, I'm going to walk you through how can we perform edge detection using Sobel, Sobel X, Sobel Y, Laplacian, and how can we perform Canny edge detection as well. Alright, so let's get started. First, we're going to import all our packages. We have done that before several times. Actually, let's go ahead and restart and clear all output. First step. And let's go ahead, import all our packages, Shift Enter, looks good. Here this is the image source. And let's go ahead and load the image. So it's pretty much the same as the image we had before. This is our image. And if you guys can see here, we just use OpenCV to read the image and then to show the image. And we have done that several times. Here we have been able to obtain the dimensions of the image. So it's 426, 640. And we had 3 channels because it is simply a colored image. And here we're going to convert it from color to grayscale. We've done that several times again. Shift Enter, looks good. Let's go ahead and see how can we actually obtain the Sobel X and Sobel Y. So, in order to do that, we can use OpenCV, cv2.sobel. We're going to pass along our grayscale image. Here we're going to simply specify that we wanted to perform Sobel X. That's why we said 0 and 1, and we can specify as well our kernel size. So here again, all these values are kind of trial and error, if you will. Please go ahead and actually try to change these values and see the impact of that on the derivative or the Sobel calculations. So here, after we obtain the X Sobel, we can just simply use OpenCV cv2.imageShow to actually show our Sobel X. Shift Enter, and here we go. As you guys can see here, this is obviously our image, but we obtain the derivative of the image in the X direction. That's why you will find the derivative is kind of, or the image resultant image is kind of heading to the kind of, like a horizontal way, or in the X dimension. Obviously, it's not very clear here, but once we plot the Sobel Y, you can right away tell that this was Sobel X. That was the derivative in the X direction. So press Shift Enter. Here, we're going to use the exact same command. So cv2.sobel. I'm going to pass along our grayscale image, same kernel size, but here we reverse them. When we say 1 and 0, that means we wanted to get Y Sobel. So Shift Enter. Here we go. So as you guys can see here, this is the derivative in the Y direction, which makes sense because as you guys can see here, the derivative is kind of, in the vertical direction, right? Which makes sense. All right, looks great. Let's go ahead and actually visualize as well the Laplacian. If you guys recall, Laplacian is simply kind of obtaining the second order derivative. So we're going to say grayscale image, I'm going to perform Laplacian, and then here we're going to use OpenCV to actually show the image as well. So as you guys can see here, this is our second order derivative. So here you still can see, let's say, Las Vegas, Nevada. Here we have still our vehicle. So the features are still kind of maintained. However, you will find that Laplacian in general, it's very noisy. It's not very clear. Like, it's really difficult to actually take an image like this and feed it to, let's say, a machine learning classifier model, for example, or let's say a support vector machine, for example, classifier, to actually tell us that this is a vehicle. This is really tough because, again, the image or the features of the image is very noisy. It's not very clear. So you will find a lot of false positives, false negatives. It's just going to be a mess. So obviously, we don't generally use Laplacian to train a machine learning model moving forward. However, we try to go with the Canny edge detection, which is kind of like a smooth form to obtain the edges of the image in a very elegant way. All right, please go ahead and review the lecture where we discussed how can we perform Canny edge detection. But the overall idea is that we are going to apply Canny to our actual image, and we're going to set the threshold, which is kind of the first threshold for the hysteresis procedure, and the second threshold for the hysteresis procedure as well. Here, again, we use kind of trial and error. We set 120 and 200, and we found that this kind of give us good results for this specific image that we have in hand. So we're going to use OpenCV, cv2.canny, pass along our grayscale image and specify threshold 1 and then threshold 2. That should give us the Canny image. We're going to use OpenCV to actually show our Canny edge detection. Shift enter, and here we go. All right, looks much better. Now we can actually see that, like the features. You can even see, like, the text on the vehicle, self-driving car. You can see, like, here we have our features of the image. Here we can see all the LiDARs. Here we can see again the Las Vegas sign. Obviously, it's still a little bit noisy here, but the features of the actual object is maintained, which is very good. That's a good thing. Okay, all right. Please go ahead and change kind of the values of the threshold 1 and 2, and try to see how that will gonna impact the accuracy of the image, okay, and the accuracy of the Canny edge detection. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it. Let's recap what we have done so far. In this lecture, we learned how can we use simply the edge detection, which is Sobel X, Sobel Y, Laplacian, and using Canny edge detection as well. So we loaded all our packages, we loaded all our image, we visualized the dimension of the image, we converted the image from grayscale to, from BGR to grayscale. We obtained the Sobel X using the cv2.sobel by specifying that we wanted the derivative in the X direction. Here we used cv2.sobel. We obtained the Sobel in the Y direction by specifying it's 1 and 0. Then here we used Laplacian to actually perform the conversion for us. And then we realized that the Laplacian is actually pretty noisy, so we don't generally use Laplacian to perform feature detection. And afterwards, we use the Canny edge detection by adjusting the threshold 1 and threshold 2, and we found that the Canny edge detection is actually pretty good and can be used extensively to perform object detection and even feature extraction as well of our image. All right, and that's pretty much all what I have for this lecture. I hope you guys enjoyed it, and see you guys in future lectures.